So finally, let us check the Vision 2030 quickly. This one actually for 6G. So do you think this one meet the current expectation of a 6G? You can check it. Specifically satellites. So actually for the current version, Vision year 2030, it tried to draw your attention to have the integration. (6G). We don't have the clear definition for 6G, but plus IoT, plus AI, or maybe we call smart. And of course, you still see virtual reality. All right, so we have the repeated emphasis about virtual reality, and so that we can have the proper communication, even you are not there. Why they want to emphasize virtual reality? Because we have the communication, even you are not here. Still, you can have the direct activation or maybe direct interaction with someone else. So we also emphasize VR. And in the video, of course, you've seen we have the emphasis on the term smart. So how to make daily life support can be smart. And how to achieve smart, we can base on AI. And of course, we have IoT, specifically the term it is sensing. All right, so we will have a lot of sensors, and those sensors can help you to do something else. For example, sensor to have the assistance to the maybe some rescue, or maybe yes, we have a sensing going through the gate. You can have the sensor to have the proper sensing. And of course, for 6G, here we don't have the clear definition for 6G, but at least we expect to have all possible coverage. You should understand for the global coverage, actually we expect to have a global coverage in the third generation system, but we don't have the successful implementation. So this time we still expect to have the global coverage by 6G to fully develop the satellite communication, and so that we have the global coverage. So that says, well, we expect to have the global coverage in 6G, fail, 4 fail, 5 fail, and right now we re-emphasize, is it possible to have the realization of global coverage in 6G? Of course, we expect yes, and so that we can have the successful global coverage in this coming generation, 6G. All right, so these are the possible visions of 2010, 20, and 30. And you have the PPT slides in PDF or in PowerPoint, so you can check the hyperlink there if you want to see more, so you can try again. All right, so this is the possible videos before we start the introduction. So let us get back to have the discussion. Cellular. Why we have the actual term cell or cellular? Because of this. Can you see a cell here? Right? This is a cell for bees. It doesn't mean cells for the biotechnology. It's the cell for bees. So we have a cell and cellular. And maybe you think, okay, you cannot see this. Yes, in the real scenario, we don't have the cell associated with the communication area. But we can have the plane like this. Why? We choose this one. In fact, you want to have an area. How about a circle? It's okay. And how about a square? It's okay. And how about a triangle? It's okay as well. But finally, we think this one will be better. Why this one will be better? Actually, if we talk about the signal strength, we expect to have a circle. But how about a circle here? Yes, it's still okay if you care about the signal strength. However, this is an area and this is a region. So we have the overlap area. You see, overlap area. Because of the overlap area, so we will have the decision. How about a boundary, a boundary, a boundary, a boundary? So if we can have a boundary, then possibly we can choose hexagon. 六角形. Here we have a hexagon. Of course, you can choose maybe the other shape to have a shape rounded to a circle. But finally, we choose this one, hexagon. And hexagon, we can have some cell, maybe cell design discussed in chapter 5. So we prefer this. If we have this, then we can have the non-overlap surface area. You see, non-overlap surface area, non-overlap surface area. So we can have the surface area, and then actually one user can communicate with the cell site. We can call this is a cell site. Cell site actually equal to base station. So we call cell site because we emphasize we have a cell. So we have the cell site, and the cell site to have the communication with the mobile stations. All right, so we can have the cell site stands for base station, and base station can have the communication with multiple mobile stations. So we have MS. If so, why we want to do so? Because someone like, oh, we can ask all the cell sites to work together. Someone like this is a city. CT1, CT2, CT3, and the other city can provide similar service to the citizens. Citizen map to mobile station. So we can have the possible service within a city, but only a city. Possibly it's an even smaller area. So it is not a city, so a small zone. And a small zone served by cell site 1. If you move outside the service area, then it should be served by the next one till, for example, you reach your destination. For example, here you have the destination of Washington, D.C. Well, for that one, we need to have a concept of a relay. Right? Here, how to have the relay. Cell site to provide service, someone like to provide service relay. And so that you can obtain the service from the source to the destination. So this is the application of the cellular communication system. Well, it looks like this. This one, we have the starting source to the destination, you see. Finally to the Washington, D.C. All right, and going through all the cells, then we will have the relay service by the cell site. So for that one, then we have the cellular mobile communication system. All right, so for example, oh, I have a cell phone, and right now I start the service, and then I move. For example, here we have a cell 1, 2, 3, and to the destination, I still can have the communication. And this kind of communication can be supported by the cellular mobile communication system. All right, so this is the one we want to study. And this one, we expect to have the universal cell phone coverage. Universal. That says the whole Earth. And then we have the cell phone coverage. Actually, the universal cell phone coverage expect to have the global coverage. I mentioned that one, it should be provided in the third generation cellular communication system. But unfortunately, we won't have the successful one. So we try again in fourth generation, try again in the fifth generation, and try again in the sixth generation mobile communication system. All right, so here we mentioned we can try many different generations. So while we have the first one around this one, it doesn't mean we have the exact one, but around this generation, we have the first generation. And first generation, previously I don't mention the system of the first generation, but the first generation likewise in Japan, in Europe we have NNT, in Japan we have NTT, and the others. Before this we may have the others. So initially, it doesn't mean we have that one, but around this year, we have the first generation. In the US, we have AMS, Advanced Mobile Phone Service. Even it's the first generation, we have AMS, introduced by AT&T in the US. And previously, I didn't know, we have a second generation. And we have the third generation. I mentioned this, right? And for CDMA, actually, we have the IS-95. All right. And I didn't know the second generation, we have IS-54 and IS-136. These are the second generation system. And about the third generation around this year, but they want to check where we can have the system service, IS-54, America, specifically North America. IS-95, North America, Hong Kong, Israel, Japan, China. Well, initially, we think the participation of cellular communication by China is too late. So, China mentioned, okay, we skip the participation in first and second generation. We will join the third generation, and maybe even for the third generation, it's not successful. China tried to jump to fourth generation. At that time, even for me, I think, okay, it's ridiculous. You don't have the background of a third generation, then you want to jump to 4G. And finally, it's true. They are correct. So they try to lead the development of the standard to 4G. And right now, they join the participation of 5G and 6G and the other generation. Even in the past, it seems to be they don't have any background for the first two generations. First generation and second generation, even the third generation, but it doesn't matter. China, they want to do it, then they achieve it. All right, so I have a really deep image about this. Even for China, we don't think they have the background for the development of the early generation, but it doesn't matter. They still can have the better development for the future generation. starting from 4G to the current 5G to the future 6G possibly. Because I should confess, yes, they are strong. All right, they are strong, so they can do that. So it's possible to have a third generation. And for the current slide, somehow like we don't have the proper status. It doesn't mean in progress, no. Maybe the past story. And study in the proper year. So third generation, what's the background? Actually based on CDMA to migrate to Huei-Wen. CDMA. So we have these. And it's the third generation. All right. So for third generation, how they emphasize, because in the past, researchers think about the capacity, TDMA not really good. And we have FDMA, AMS actually is FDMA, not so good. So they think CDMA will be the best option. So they developed the extended version to the wide-band CDMA so that we have these. And this is a concept for the third generation system, wide-band CDMA. And you see, CDMA focused by China as well. So we can see one possible activity by China. So even it's too late for them to start, but they can catch up. So you cannot think, okay, you don't have the background, so you will ignore the possible progress made by China. Yes, they contribute to the development of the future standard. Well, compared to 2G, so that to have the 3G, we always have this low rate to high rate, low mobility to high mobility. So you can look at these. We expect to have a high speed. We expect to have a high quality. We expect to have a wide spectrum. We expect to have a great capability and scheduling, link adaptation, etc. Specifically, we have IP here. For second generation, we don't have the concept in the mobile communication system, but in the third generation, yeah, it's successful to have IP. So at that time, they want to emphasize OIP. Maybe right now you think OIP is natural. IP in internet, IP in everywhere. So OIP obviously is okay. So third generation at that time, they emphasize OIP. This aspect is successful. All right. So we have IP, mobile IP and IP-based service provided by the third generation system. All right. So this one. I want to emphasize using the current example, 2G to 3G, 3G to 4G, 4G to 5G, 5G to 6G. We always have the requirement, lower rate, low mobility to higher rate to high mobility, and the lower quality to high quality of for example, the videos. Well, this is 3G. And here to 4G, we have this. 4G, we have a long-term evolution. So we have a LTE. And actually, China focuses on the 4G, so China has its own version. And if we focus on the China's version, it should be this, TD-LTE, but it's a version of LTE. And even in Sweden, US, in South Korea, they adopt FDD-LTE. But at least, China focuses on its own standard, and it's successful. So we can see the contribution from China. So we have a 4G, and 4G actually it should be LTE. And later we have the advanced version. So we have a long-term evolution advanced. So we have LTE-A to have the later version in the 6G. So this is 6G. All right, so we can have the others. So we may have the others. I skip some of them. So we have a 5. And we have a 6G later. But currently, we don't have the specific description for that. And you can see about the subscription. If we have a second generation, it should be the major one, then we will make the previous generation fewer. And of course, we expect to have the growth of the future generation, 3G. And likewise, you can change the role. How about 3G here, and 4G, and 5G? And likewise, it should be 4G, 5G, and 6G. Similar trend like this. And so that we have the subscriber growth for different generations. Specifically using the way 1, 2, 3, 2, 3, 4, 3, 4, 5, and 4, 5, 6. It's applicable, so we can use the trend, but we should have a shift, year shift, so that, oh, okay, we have the new generation, new generation, new generation. And we always repeat a pattern like this to have the subscriber growth. All right, and of course, for a year, we should mention, oh, okay, we won't provide some support to some generation animal. For example, this one. Third generation, oh, okay, maybe around here. Around year 2000, we won't support the third generation animal. So sometimes you need to abandon the really old version to start the newer versions. All right. Okay, so we have the requirement for the later generation to have a higher rate, higher mobility, better quality, etc. And about the coverage, actually we try to have the global coverage. As for the others, actually we can achieve those in the, for example, in the first generation, in the second generation. But for the global generation, we expect to have the global generation in the third generation. However, it's not successful. So global generation will be a key, right? From third generation even to the sixth generation, we still expect this. So this one is a key. Because it's a key, so how to have the key? Satellites. Well, maybe you have a question. Why satellite is still a key? First one, techniques. Second one, can you imagine the second one, the second reason? Cost. Someone like right now, we have NVIDIA, computing power. In the past, do you think it's easy to afford high computing power? No. But right now, maybe the current year 2026, it's okay to have the computing power or to afford the computing power. So we make it possible. Because it's possible, so we can have the further development of AI. Because AI rely on the heavy, it should be the heavy computing power. So of course we rely on that one. And right now it's okay, affordable. So we can have the fast development of AI. And so that we call right now it should be the AI, maybe AI era. So we have the new expectation. And likewise, we have a satellite. Satellite, we have the similar reason. Yes, we don't have a lot of satellite. We rely on the new techniques for the satellite communication. And also, we expect to have more satellites. So a direct reason should be cost. So can we provide more? And so that we have the cost-effective solution to provide more satellites. If yes, then, oh, okay, we think the era of satellite communication comes. And do you think it comes? Maybe yes. So we expect to have 6G generation can allow satellite to realize the real global coverage. So that's it. But let us have the mapping to the previous coverage. How about macro cell? Macro. So macro, it should be the coverage of suburban area, 就郊区. And micro cell, it's urban area, something like metropolitan area. And pico cell is the coverage within a building, so in-building coverage. Then we have the pico cell. So possibly we can have the smaller one, smaller than micro cell, we call it a pico within the building. And this one, urban area and suburban area, and beyond suburban, we will have the global coverage. For the global coverage, we think how to have the best realization, of course, for the whole Earth. All right, because it cannot reach the whole Earth, so of course, we expect to have the development of the 6G generation. Well, we can talk about these. Even right now, it doesn't mean we have the 6G included, but at least we have the concept of satellite. So you can think 6G should be included in this one. But we draw your attention to check data rate, mobility, and mobility from stationary to pedestrian to vehicular. So we have a mobility. And the data rate from really low to 100 megabit per second. So look at this. GSM here. GSM provides us a really low data rate. And then we have the satellite UMTS, it should be the third generation. So we expect to have the global, actually it should be the, or maybe we have the right coverage to cover the diversity of data rate and the mobility. All right. So we have 3G to 4, 5, and the other. So we expect that one. Unless for second generation, no. Even we can support stationary, pedestrian, vehicular, but only a really low rate. Why? We have a really low rate because of the techniques. Communication techniques cannot support. And for the new generation, new techniques, then we can support higher data rate, and also the high mobility. All right, so this one. And look at this. Even for satellite, we think we have a broad range. But someone like, look at this. We have a trend for satellite for the wide or broadband system. We can provide rate from low to really high. However, how about the mobility? Maybe from stationary to pedestrian only, not provide the service to the vehicular. So that says for the techniques, we may have some limitation for all of these. All right, so this is the extreme case possibly, but we expect to have a case like this. All right, and so that we can cover high mobility and also cover high data rate, as mentioned in the previous expectation, low rate to high rate, low mobility to high mobility, and so that we expect to have the future generation here. All right. So up to now, we focus on cellular network. So this is the branch we've checked. All right, and actually we can have the first generation to the current generation 6G. It's okay, but don't forget we still have the other service. And first of all, how about global positioning system? Specifically, satellite assisted one, yes, we have it. And these are the accompanying system. We have a GPS. And in fact, within a building, sometimes cellular system it is not okay. So we expect to have a home networking, short range communication. And if even not really short, but at least we can have a bit longer communication system using wireless local area network. LAN says it's local area network. Here we have the subtitle local area network, LAN. And PAN, P means personal area network. Well, up to now we have this, and in fact we have the short range one, including this, Bluetooth. All right, and in Vision 2030 we have a sensing, so we have a sensor network. All right, we expect sensor to have the sensor network. So sensor network to IoT. Why? Because of a sensor, so we can ask those sensors to work together, and those work together then can provide the Internet of Things. So we can have a sensor network to have a sensing, to have IoT, IoT plus AI. Then we have a IoT. All right, so we expect that one. And recently, we want to have the solution. How to have the solution? Actually, we can have an AI-based solution. So we have a machine learning based. All right, so AI or machine learning based solution. So it's possible. That says in the past, maybe we have the Protocol design, then we want to have the smart feature. To have the smart feature, we expect to apply AI. So it's natural to use some of the algorithm in AI or in machine learning to enable the possible solution. So here we can have the AI-based solution or machine learning-based solution to enable all of these. All right. Well, up now, we still fail to mention one network, this kind of network. AHA network. AHA network is a specific network in military. Military, we need to have the communication, so we can have, we have build some of maybe not build. We try to have the possible communication using the peer communication. That says, I have a device, you have a device, and we have the other device. Is it possible to have the collaboration? I send to you, you send to them, and send to the other so that we can reach the destination. If so, then we can have the peer communication to form the ad hoc. So, ad hoc compared to the infrastructure. What kind of infrastructure? Oh, in the second generation, we think we should have a mobile station supported by a base station. Base station supported by the mobile switching center. We have some infrastructure of a base station and mobile switching center. Some infrastructure like those. However, for AHA, should we have the infrastructure? No, we just pass on all the peers here, and then we can have the possible communication. And those can provide you the peer communication and that kind of peer communication to form the AHA network. So AHA network says, okay, should we have the infrastructure? No. All right. Can we have the possible communication based on all the peers? Yes. And so then we have the AHA network. And the AHA network possibly can be a vehicle. So AHA network can be a vehicle. So we have a vehicular AHA network. So we have a VANET. All right, and we have IoT. So how about vehicular? Vehicles. Then we have IOV, Internet of Vehicle. So we have all the possible variants of the network type. So based on some of the network, and if we focus on the specific nodes, vehicles, and so that we can have the VANET, and so that we have the IOV, and so that we have the new generation network. So they are possible. So that says, in the current one, initially we focus on the cellular mobile communication network, and actually we can have the others. All the network collaborate together to provide the service to human beings, and so that we can have the facilitated communication easily. Even we have the heterogeneous networks, but we can have the smooth service provision by all the networks. All right, that's it. Well, I should let you know this first. Ad hoc. Meant or happening only for a particular purpose or time or as needed, not planned before it happens. So this is called ad hoc. All right, so compared to infrastructure, we will have the ad network. Well, let me stop here and allow you to have maybe to think about how we have the other networks, and also you can feel free to have the discussion with the other members. Okay, then you have 3 minutes to refresh your brain, and also you can stand and so that you can walk around to have the discussion with your classmates. Okay, go and check. So feel free to stand up, and of course you can know each other for sure. So I think maybe if necessary, you still can have the private communication, but the second class is up, so let me start here. And we will continue this Wednesday. And of course, I've checked the number of students enrolled in the class, maybe around 5. So I'm not sure. Is it possible to have more students to join? I'm not sure. But at least, if we have fewer students, then no TA to assist us. So that's a real situation. All right, that's all. And actually, we have 5, maybe 1 from Germany and maybe one international student as well, one Taiwanese as well, but I cannot see. And you are from Double E, right? Department of Double E, right? So are you Taiwanese or Indonesian? Okay, Indonesian, Thai, right? Taiwanese. And another Taiwanese, I'm not sure, another Taiwanese will stay here or not. And one from Germany. So we have 5 at this moment. All right, that's all. And hopefully everything's okay. And that's all. And before you go, any questions? If no, that's it. And see you this Wednesday. Bye-bye.